So linearity has to be given an appropriate importance in your power amplifiers, and we have a measure called adjacent channel power ratio ACPR. So this will exactly say how much adjacent channel power is getting overlapped with your current channel power. That is going to be the unwanted thing of our unwanted power, which is going to be lossy in nature. Also for amplitude compression, we quantify it by BER, bit error rate. So better bit error rate is going to be larger. It means the output power is less, which will be due to because of amplitude compression. So linearity has to be handled seriously in power amplifiers. If you don't handle linearity, the application will become completely noisy. And you have this non-linearity happening because of intermodulation and compression. Intermodulation, it is MF1 plus or minus NF2, and compression, when you increase the input power, the output power is reducing and it is not increasing. So if you're employing two sufficiently large tones, the former tone provides some indication of ACPR. The amplitudes are chosen such that one component is 6 dB below the other component, so that you can clearly say whether the two tones are interfering or not. Tone they mean by frequency. Okay, so you supply two frequencies in such a way that one frequency power is 6 dB more than the other, and after passing the power amplifier, see the spectrum and see how they are related. If they are far away, the power amplifier is working in the linear region. If they are overlapping or if they are very close, then non-linearity is affecting your power amplifier. So this will clearly give how much non-linearity you have in the power amplifier. And see here, we have seen this already, 1 dB compression point. So as the input increases, the output will increase, and after some time it will start decreasing, but it has to go straight. So how much it has decreased, that is going to be your 1 dB compression point. So 1 dB compression point will clearly say that the output has started to reduce and it is not increasing as you understand.